Good morning, everyone. Welcome back. Thank you for joining us. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, the Science and Technology channel.
Yep, and we're talking about a science topic involving the space. And yeah, there it is. This odd named asteroid, odd shaped.
Donaldjohanson asteroid.
Yeah, it's kind of weird looking.
That's
So
the dude that probably found it, right?
yeah, I guess. Yeah,
First found it.
I got dibs on that one. So, but yeah, let's get into it.
All right. NASA's Lucy spacecraft, and I didn't even know NASA had a Lucy spacecraft.
I don't think we've ever talked about that.
I know. Revealed that a bizarre wobbling, peanut shaped asteroid holds surprising clues about ancient water and the origins of the solar system. Even a relatively small asteroid can have a surprisingly dramatic history. During a close flyby of the asteroid Donaldjohanson, I'm not making that name up, NASA's Lucy spacecraft discovered an oddly shaped world that wobbles through space, bears scars from an ancient collision, and even preserves evidence that liquid water briefly existed on its parent body long ago. Would you like to know more?
Pretty interesting. The asteroid formed about 155 million years ago when fragments from a violent impact slowly came to get back together. Since then, sunlight has steadily altered its rotation through a subtle but powerful process, leaving behind clues to its long and eventful evolution.
On April 20th of 2025, Lucy flew within 650 miles of Donaldjohanson while traveling through the main asteroid belt on its way to the Jupiter Trojan asteroids. The spacecraft captured the first detailed images and scientific measurements of this previously unexplored object.
So 650 miles, that's pretty close in space terms, right?
For space, yeah.
Yeah. I mean, that's like from here to Salt Lake City, roughly. So,
Yeah, their cameras can easily pick up stuff on that asteroid.
yeah, pretty close. Rather than rotating around a single axis like most planets and asteroids, Donaldjohanson was found to have a much more complicated motion involving two separate rotational movements. The flyby also revealed its distinctive peanut-like shape, along with numerous craters and ridges covering its surface.
The encounter served as a full scale rehearsal before Lucy begins exploring the Trojan asteroids, starting with its flyby of Euripides on August 12th, 2027. And we're gonna keep you informed of that because that's going to be big news. Everything aboard the spacecraft operated as planned. That's good. While scientists gained an unexpected opportunity to compare Donaldjohanson with two better known asteroids, Bennu and Ryugu. And I think we talked about those, Scott. We've talked about those two. They sound familiar. Those two bodies have similar compositions but follow very different evolutionary paths after the formation. The Lucy team's initial findings were published June 18th of this year in the journal Science. It's a couple weeks ago.
Yeah. Before Lucy arrived, astronomers using Earth-based telescopes noticed regular changes in the asteroid's brightness, indicating that the elongated object completed one rotation every 10 and a half Earth days.
Lucy revealed that the situation is much more complex. Instead of spinning smoothly, Donaldjohanson behaves more like a wobbling top. It rotates end over end every 10 and a half days while also rocking back and forth along its long axis every 26 and a half days. Now that sounds complicated.
Yeah. Earlier observations suggested the asteroid was elongated, but Lucy's close-up images showed that it is actually a bilobate object consisting of two connected lobes separated by a narrow neck, giving it the appearance of a peanut, which is what Steve said earlier. It does kind of look like an odd-looking peanut.
Yeah. Scientists believe these two lobes were once separate fragments created during an asteroid collision. Their own gravity eventually pulled them together in a single object.
Researchers estimate that Donaldjohanson originally spun at least 10 times faster than it does today. I don't know how they would figure that, though. Over the past 20 million to 60 million years, its rotation gradually slowed. As the spin decreased, the balance between gravity and centrifugal force, allowing loose rocks and debris to slide downhill and soften the appearance of many impact craters seen in Lucy's images.
The researchers believe the slowdown was caused by the Yorp effect, YORP, not making that up, a process driven by sunlight. As the sun warms different parts of an asteroid's surface, those areas release the absorbed energy as infrared radiation. Although the force produced is extremely small, an unevenly shaped asteroid experiences a tiny twisting effect that can gradually alter its rotation over millions of years.
This same process can either slow or speed up other asteroids. Bennu, for example, now rotates once every 4 hours, while Ryugu spins about once every 7 hours. That's pretty amazing. That's pretty fast. Scientists think both of those asteroids once rotated much more slowly before the Yorp effect accelerated them. Huh.
As Lucy sped past Donaldjohanson at roughly 30,000 miles per hour, its instruments detected iron-rich clay minerals on the asteroid's surface. Man, that's going fast. I can just see it taking all those pictures.
Yeah, quick.
These minerals could only have formed in the presence of liquid water sometime in the distant past. However, researchers concluded that the water was present only briefly because prolonged exposure typically replaces the iron in these clays with elements such as magnesium.
Huh. That contrasts with Bennu and Ryugu, where scientists found magnesium-rich clay minerals that point to much longer periods of water exposure, possibly lasting millions of years, while those asteroids were still part of the larger parent bodies.
The different mineral signatures suggest that the parent asteroids may have formed at different times or in different regions of the early solar system before eventually ending up in the main asteroid belt.
Donaldjohanson is believed to be made from the remains of a larger asteroid that contained both carbon and water and was shattered in a collision within the main asteroid belt. Scientists think Bennu and Ryugu share a similar origin. The differences, however, are just as important.
Donaldjohanson formed only about 155 million years ago, making it far younger than Bennu and Ryugu, which originated roughly 1 to 2 billion years ago. It has also stayed in the asteroid belt throughout its existence, while Bennu and Ryugu gradually migrated into orbits that periodically bring them close to Earth, making them ideal targets for sample return missions.
Quote here, it's helpful for scientists to compare Donaldjohanson with asteroids like Bennu and Ryugu. I wonder if those are names of people that discovered them.
Probably.
Which are seemingly similar asteroids, because every subtle difference is another clue to our original or origin story. That's according to Simon Marchi, Lucy Deputy Principal Investigator and lead author of the study at the Boulder, Colorado office of the Southwest Research Institute.
Quote, once we started learning more about the Trojans, a completely different population of space rocks with very different histories, our understanding of solar system formation is destined to be challenged, said Marchi.
Donaldjohanson is only a preview of Lucy's primary mission, named after the famous fossilized human ancestor discovered in Ethiopia in 1974. I don't ever remember hearing any about that. So,
No, I don't either,
yeah. Lucy will become the first spacecraft to explore Jupiter's Trojan asteroids. These ancient, well-preserved objects formed during the earliest days of the solar system and may help scientists better understand how the planets formed, migrated, and eventually settled into their present orbits.
I didn't know about the Trojan asteroids either. This is fascinating.
Yeah.
Pretty cool.
Yeah, very cool.
We'll keep an eye on this next year when it reaches those asteroids.
Yeah, I wonder how long this mission is going to be going on for. It's pretty cool.
Could be indefinite.
Yeah. Until it burns out or stops talking back, I guess. So.
Yeah, Voyager's what? From the 70s?
70s. Yeah.
Still going?
Yeah, still going. Lost contact for a little while, but yeah, came back. So pretty cool.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
See you this afternoon. Thank you.